So lesson 3, I skipped lesson 2 this year because of the job situation. Introduction to vectors. In physics, any quantity is either a scalar or a vector. You hopefully all learned that last year. Scalars, if you'll recall, have magnitude only. Vectors have both magnitude and direction. Some examples. Displacement is a vector quantity, 6.5 kilometers west. Velocity is a vector quantity. How about 3.8 meters per second north? Acceleration is a vector quantity, 9.8 meters per second squared down. What was another way that I could show the direction down? Negative, although this year, especially in the forces section, especially when we have more than one mass, we may ditch the down always being negative. Sometimes we'll find it much more convenient in my winner minus loser forces approach to let down be positive because the math is cleaner. But yeah, negative usually means down. Momentum, 3.9. Who remembers the units for momentum? So there wasn't anything official. Momentum, who remembers, was what times what? It'd be convenient if my teacher had given me like a colored reference sheet that maybe had some equations on it with like headings and things. And maybe there was even a heading that said vector momentum. And, oh yeah, the symbol for momentum wasn't M, because M was taken by math. It was P for product. And momentum is what times what? So mass is measured in units. Mass is measured in kilogram. And velocity is measured in. So momentum is kilogram meters per second. How about west? They haven't shortened that one. Because a Newton is a kilogram meter per second squared, and we've named that a Newton. I think I mentioned to my students last year, they are talking about naming this one kilogram meters per second. They're talking about renaming it an Einstein, because he doesn't have a unit named after him, and he probably should. Force, 12 newtons at 36 degrees west of south. There's a vector. Scalar quantities, distance versus displacement. Distance is the scalar, 205 centimeters. Speed is the scalar. Hey, how about freeway speed, 110 kilometers per hour? When did that change? I don't know. It's always 100 when I was growing up, but suddenly, oh, it's faster now. 22 seconds, what are we measuring there? Time? Volume, 8 liters. By the way, when I use liters, I always draw a cursive written L, because if I draw a lowercase l, what does that also look like? A 1, and I'm terrified I'll think it's 81. So, worker energy, 19, what was energy or work measured in? Joules. Now, you know what? You could have negative 19. That was not a directional component. That was simply saying you'd lost energy, which is not a direction. That's still quantity. That's still a value. That's still a measurement. Less than before. We had scalars like normal math. 6 plus kilograms plus 8 kilograms is 14 kilograms. But to add vectors, we add them vectorially. And I'm going to go through this. But the key idea was, how do I add two vectors? I draw them tip to tail. And then the answer is from the tail of the first to the tip of the second. Remember that from last year? So I'm not going to walk through. I'm cutting corners because I don't want to have a whole bunch of homework for the weekend. So let's jump to example 1 here. So example 1 was add 5 kilometers west to 8 kilometers north. I always, anytime that I'm doing a vector question, draw a compass rose if I don't have one on the page. Somewhere I go like this. And then In physics, I tell kids I have two approaches when I don't know what to do. One of my first approaches is I DALP. Who remembers what DALP stands for? Draw a little picture, okay? So in this case, what was the first vector? I've scrolled down, but you have it. What was the first vector, magnitude and direction from example 1? 5 kilometers west. So west points this way, and I'll label that with a 5 kilometers. And I'm going to try and draw this roughly to scale. What's the next vector that they want me to add to it? Magnitude and direction, Jordan. So 8 kilometers isn't quite twice as big as 5, but it is bigger. So I'll draw about like that. And this brings us then to the punchline. How do I add two vectors together? Why, I draw them. What did you say, Mark? Now you can either go 5 and 8, and that's your resultant. Or, don't write this down, you could go 8 and 5, and that's your resultant. What I want you to notice is you get the same resultant. Adding vectors, order does not matter. I usually tend to go in the order that they gave them to me, but that's only because I'm kind of hoping my answer will look like yours in terms of a picture, but every once in a while it's much more convenient to draw the second one first and then the first one and go ahead. Let's label my sides. This was 5. This was 8. I'll call this vector symbol R for resultant. How can I find the magnitude of this particular vector? Pythagoras. I am fine if you are comfortable enough with Pythagoras to go straight to your calculator and go 8 squared plus 5 squared equals square root. If you can go straight to that and show no work in your homework, I'm good with that, Josh. On a test, I'd probably show the work because I don't want to make a mistake and I want, just in case I trip on my brain. And in our notes, I'll write down that we use Pythagoras this time so that when you're studying, we know what the heck we did. So I'm going to write 8 squared plus 5 squared equals R squared. But honestly, I would have no problem in your homework if you're doing vector math and you can get the magnitude and you jump straight to this and you say, oh, R is 2 or 3 sig figs all year long, so 9.43. Units, kilometers. And why is this wrong? Because it is. Yeah, see, I found the distance, and I think the question wanted the displacement. So now I have to get a direction. At. To find the direction, Naomi, we go to the origination of our resultant. This is the angle that I want. Not on the tip, but where it started from. And this is a tricky part that kids struggle with. That particular angle, Grayson, I'll call it angle theta, is going to be what of what? North of south, east of west? What of what? What is that one? Okay. North of west. Now, if you have trouble with that, I don't mind helping you, coming after school, explain it. Some kids really find it tough. I always tell a story of one of my kids a few years ago, Dylan Gattner, one of the top kids I've ever taught, could not figure this out. And so he simply memorized all 16 permutations. He drew north of west, south of west, west of north, south, and he just memorized what went with what because he just couldn't wrap his brain. And okay, it worked for him. It's kind of a brute force approach. It is worth wrapping your brain around. The of, north of west, is always the horizontal or the vertical line that your vector is originating from. The first part is what direction from that horizontal or vertical line you're drawing to get to the vector itself. This is north of west. How big? Well, I have a right angle opposite adjacent, which trig function? It'll usually, not always, but usually be tangent. And how do I find an angle? As we said yesterday, inverse or second function tan. And I get 58 degrees. north of west. Right? Come back to you? Good, then let's skip example 2. On your tests, because I designed this course back when there was a provincial, on the old Physics 12 provincial exam, there were, I kid you not, Nate, what I will call essay questions. They weren't exactly essay questions. Here's what they were. They would give you a question to solve, and then part B would say, suppose you change the battery from 6 volts to 3 volts. Using principles of physics, tell me what would happen to the resistance now. Or suppose we doubled the mass of the car. Using principles of physics, tell me what would happen to the speed now. They're using principles of physics questions. And I will give you one of those, sometimes 2, on almost every test, because they're good ways for you to start really wrapping your brain around the concept, around the generalization. You don't have to answer them as essays, and in fact, what you're always allowed to do is make up reasonable numbers, crunch the numbers, and then show me your conclusion. But I will almost always teach you how to do them algebraically, because I'm an uber nerd, and how can I resist the chance to show you how to think a little abstractly? Here's a using principles of physics question. It says this. If we add displacement vectors of length 3 meters and 2 meters, what is A, the maximum sum, and B, the minimum sum? You know what? I'm going to go like this. Here's my answer to A. Here's my answer to B. What is the maximum sum that you can get from vectors of 3 meters and 2 meters? Convince me. But 3 plus 2 can also be 1. Convince me. You gave me a scalar answer. Convince me. Can you give me that? Give me the same thing that you said, but can you add some directions, please? In other words, don't say 3 plus 2. Say 3 something plus 2 something equals 5. That's not directions. Those are units. Brian, right? Eric. Son of a mother. I'll live with that. You know what? I'm going to go, Eric, with a I'm going to go with a picture being worth 1,000 words, and I'm just going to go like this. 3 plus 2 equals 5. I'd take 3 north plus 2 north equals 5 north, but whenever I can use a picture, that's my fallback, much like the whole free body diagram rant that I often went on last year, right? Now I'm going to come back to you, Brendan. Can you see why I was also able to say, when you said 3 plus 2 equals 5, I said, well, 3 plus 2 can equal 1. How could I draw that so 3 plus 2 equals 1? 3 right plus, yeah. I think that's the minimum. Everything else, any other way you add those vectors will be at some tip-to-tail angle, and it's going to be between 1 and 5. And then some degree angle theta. Okay? There's a perfect, now it says, explain your answer using relevant principles of physics. What I want you to realize is I'm not looking for an essay, I'm looking for a clear explanation, and sometimes a picture is worth 1,000 words, a good free body diagram, a couple of arrows, and then maybe a conclusion, or sometimes writing an equation showing how, everything in the equation is on the bottom, so anything on the bottom makes the answer smaller if it gets bigger, or whatever. How do we add 3 vectors? Honestly, the short answer is you don't. By the way, there is no way to add 3 things all at once, even with numbers. When I say what's 3 plus 5 plus 8, you have to go 3 plus 5, get an answer, plus 8, get an answer. There is no algorithm to add 19 numbers all at once. It's you add 2, add the next one, add the next one, add the next. Well, it's the same with vectors. How do I add 3 vectors together? I add the first 2, then add the third one. So let's add the first 2 as a picture. Oh, wait a minute. It wants me to draw 2A. How could I draw 2A if this is a picture of A? What would 2A look like? Twice as long. I'm eyeballing it, but that's pretty close, yeah? Try and be roughly to scale. Plus B plus What would 0.5c look like? Yoink. So there's two ways I can think about this. As a picture, it's going to look like this. 2a plus b plus half of c. There is your resultant, something like that. And if I had actual numbers, Josh, what I would do is I would figure out what 2a plus b is using Pythagoras. I would get an answer, draw that vector, then add 0.5c to it, tip to tail. But it would be pretty yucky because I'd be adding a slanty vector to a slanty vector. It would be a job for the cosine law and the sine law and lots of trig. I could do it. I'm not going to throw that at you. You won't be asked to add, sorry, that's a lie. I was going to say you won't be asked to add 3 vectors together. The only time you'll be asked to add 3 vectors together is if you know the answer ahead of time. If you know the answer is 0 and you're actually finding one of the missing vectors. In other words, if you know you're supposed to come back and close the triangle. An object is initially moving at 3.0 meters per second east. It accelerates south at 1.5 meters per second squared for 4 seconds. Find the final velocity by adding Vf equals Vi plus At. I did this last year with my physics 11s. I don't know if Mr. Kamosi did. This is a familiar equation, Vf equals Vi plus At. But what I want you to realize is in physics 12, it also works with pictures. It also works with vectors. Mark, what is VI, magnitude and direction, please? Read it to me. So, have I turned the page? Wrong mark. I was going this mark, but that's okay. I got Zach's and marks everywhere here. Good gosh. So it's going to be Mark A and Mark. Anyways, keep going. Mark A in the back. Let's see. I got to draw a compass rose because I've turned the page. 3 meters per second east. What do you think? Yoink, about like that. Plus. Other mark. What's the acceleration vector, magnitude and direction? Just read it to me, kiddo. It accelerates what at what? Missed the direction. I need the direction. Okay, so 1.5 meters per second squared. I guess in my picture I'm going to point that down. Now, don't draw this yet. It's going to be that, but then it's going to be times 4 times a scalar. So what is 4 times 1.5 in your head or on a calculator? 6. I'm going to draw a vector 6 long, twice as long as the 3 pointing down. That is the picture of V final. Rafi, it's going to be 3 to the right plus 6 down, whatever the heck that is. Hey, how would I add those together? Any suggestions? How might I draw them? Tip to tail, you say. So it's going to be 3, 6, yoink. And instead of calling it resultant, since it's from an equation, I'll call it V final, because that's what they told me it is. Lovely right angle triangle. Let's get triggy with it. Do the Pythagoras. You know what? Let's do the Pythagoras going straight to the answer. Let's see if I can. It's going to be, because I have a good calculator, 3 squared plus 6 squared, square root of 45. 6.71 to 2 or 3 sig figs. I'll go to 3 sig figs. Meters per second. Now that's the speed. How do I change this into a velocity? At, not south. Neither is, oh, you know what? It's going to be find theta and then what of what. So go back to where your vector starts from. That's where the theta is, and to get to that vector, I draw like that. Angle theta, let's see. Opposite, adjacent. Which trig function, again? Usually going to be, not always, but usually. opposite over adjacent. I get a theta of 63.4 degrees. What of what? North of south, east of west? What of what? South. Oh, put in that symbol. No, I got the at symbol there, Mr. Dueck. South of east. I'll try and make my capital S's really curvy and large so you can tell they're not 5s because my handwriting is atrocious. I would hate you to think, oh, that's 63.4 degrees 5 of east. So all the equations that we did last year that had vectors in them can actually be done as diagrams. Now that's actually fairly advanced. That's actually the question we just did a little bit beyond the scope of Physics 12, but it's always kind of cool to show you that it works. What is fair game? Airplane questions. Applications. An airplane has an air velocity, or an engine velocity, of V1 equals 200 meters per second north. There's a wind blowing at 60 meters per second, 35 degrees south of east. What's the plane's ground velocity? You know what I'm going to do, Max? First thing I'm going to do is draw compass rose, because I've turned the page. If you have one on your page still, fine, but... What we're really saying is this. When you combine the engine speed of the plane with the direction that the wind is pushing it, if you add those together, that's what the ground sees. As an equation, V engine plus V wind equals V ground. Oh, Mr. Dueck, the answer is 260. No, Grayson, I can't just add the numbers. They're vectors. Dulp. This one's got some slanties in it, so I'm going to draw this one really carefully. I mean, I'm okay on V1. 200 north, that's the engine velocity. I think that's going to look yoink, like that. And I'll draw it fairly big because 200 is a fairly big number. Plus... Grayson, can you read me V2, the magnitude and direction, right from the question? What is velocity 2?
16 meters per second at 35 degrees south of east.
What of what? What of what? What of what? Say it again. You're right, but I'm making a point here. One more time. What of what? South of. South of. That's what I'm going to draw first, okay? The of part, I'm going to draw a dotted line pointing to the east. What direction am I going to go of east? See how we put it all together? Down from, so start here, go down from here. How many degrees am I going to go down from here? This is how you put it all together, okay? So I know some of my students struggled with that last year. It's going to be 35 degrees. How long will that line be? Its magnitude. Yes, so about 1/3 as long as that 200 that I drew if I really want to go to scale. So if you have a slanty one and you're asking, how do I draw it? You almost, Grayson, go backwards along the data. Although we read 60 meters per second at 35 degrees south of east, it's draw east first, go south, 35 degrees for a length of 60. Okay? How will I add these together? Tip to tail. I wrote down here, when we draw the vectors tip to tail, we get the following triangle. I'm going to do the triangle up here because I think I'm going to need enough room to use, because this is going to be like cosine law and stuff. This is not going to be SOHCAHTOA. So as a picture, it's going to look like this. 200, yoink, 60. Where is the resultant? From the tail of the first one to the tip of the second vector. Yoink. That there is the, what I'm trying to find, ground velocity. Now, I got a bit of a problem here because I need to get an angle inside this triangle, and the only angle that they gave me is they told me this one here is 35 degrees because south of east. Can anybody see, how does that help me figure out this one, this interior angle? Yeah, fancy word, they're complementary. They're going to add to 90. So 90 minus 35, don't forget to carry the one, 55? Now I've got my triangle. I've got an angle inside. I've got two sides. Is this SOHCAHTOA? Is there a right angle? No. Is this sine law? No pair. You know what that means? What's left? Cosine law. Now, what's the cosine law? The cosine law, conveniently on my formula sheet, said c squared equals a squared plus b squared minus 2ab cosine big C. Mark, was a little bit of a problem because, Mr. Dueck, you didn't give me any A's, B's, or C's. Mark, what are we trying to find, sir? Okay, that by default then is little c. What's big C? What's A and B? The other two in any order, I don't care. And that's why I've always said I never really have memorized the cosine law formula. I've memorized the cosine law pattern. This is what I'm trying to find. This is the angle that goes with it. Or if this is the angle that I'm trying to find, this is the side across from it. The other two go here. It's going to look like this. C squared equals 200 squared plus 60 squared minus 200 60 cosine 55. Sadly, he's not here, but if Joseph were here, I would say, Joseph, if you have a good calculator, you should be able to type this all in one fell swoop and see it all in one big line. Cheap date, he does not. So, but those of you, hopefully by now, have a decent calculator. You can type all this in one fell swoop. Don't forget you're finding c squared, so make sure on your last step, what are you going to do? Yep. You get, to 3 sig figs, I guess 173. Oh, instead of calling it C, now I'm going to go back to the actual variable. What did you say we were finding, Mark? So VG equals 173, was it meters per second or kilometers per hour? Meters per second? What did you say we're asking us to find? What we found is the ground speed. How do I turn this into a velocity? I need a direction. At what direction? Well, I go look at my resultant, and Josh, I go back to where it started from, and I notice conveniently I do have an of right here. It's going to be of north because I got a vertical or a horizontal line. I wouldn't want to try and use this line because it's slanty. So I'm going to put my theta right here. It's going to be what of what? North of south, east of west, what of what? It's going to be east of north. Okay. You know what? I'll even fill that in. I'll leave a space. East of north. And I need to find theta. Okay. Can I use SOHCAHTOA? So this is not going to be tangent. This is not going to be tangent. Is there a pair? There is now, because I just figured out that this is 172.73 blah, 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 blah. So, sine law or cosine law? I can use the sine law. going to do that right here. Sine of 55 over 172.73, blah, 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 blah. In fact, I'm going to use my answer button for that value on my calculator, and that way I'm not rounding off at all. Equals sine theta over 60 or over 200. Okay? The one across from it. 60. Knock, knock. Knock, knock. One fraction equals one fraction. Stuff will move diagonally. Again. Now, I can't quite get the theta by itself, but Naomi, what I can get by itself is the sine theta. The 60 is going to move to the top and in front, multiply. Oh, and then I've got the sine theta by itself. I get this. Sine theta equals 60 sine 55 divided by 172.73. If I know that, how can I use that to find the angle? How can I find an angle? You all know this, you just don't realize you know it. Shift sign, yeah. I'm going to type in the right-hand side, so I'm going to go 60 sine 55 divided by, and I'm going to use my answer button because it's not 172.73. It's really 172.7256945, blah, 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 blah. And then I'm going to go shift sign of that value. So I'm going to go shift sign, answer button again. I like this question. I like this question. I like this question. Rob, why would I say that? Did you hear me say it was going to be on the test? Or are you the kind of student who notices when a teacher tends to emphasize certain things, when a teacher tends to really repeat himself, you notice that must mean that it's a question or a topic or something the teacher, oh, you're a good student. I'm glad you noticed that. Do you get 16.5 degrees? There's my ground velocity. By the way, Mark, I got to point out, it's bad physics, but airplanes would call this your ground speed. I know they mean ground velocity, but it's often called engine speed, wind speed, and ground speed, even though they include the direction. So just in English, you may hear that called ground speed, but it's a velocity. Turn the page. If you are very uncomfortable using the cosine law and the sine law, and that's okay. It is possible to do this whole course without ever once using the sine law and the cosine law by breaking everything into components. By taking the 200, oh, the 200 was north, wasn't it? And then taking that 60 and breaking it down into that and that. Remember doing components? And that is perfectly fine. You would do the trig to find those two values. Then you would go up plus down by subtracting, gives me my overall up. I have one to the side. You would then add those together tip to tail. Then you would do Pythagoras. Then you would find theta, probably by using tangent this time because it's a right angle. And then you would have the answer. Humbly, I suggest cosine law, sine law, tougher, but way faster. So I often in the past have worked through the entire component method. Here's what I'm going to say. If you want the component method, and there's nothing wrong with using the component method, see me after school and I'll show it to you. But I'm going to nudge you as a math nerd to say, look, we taught you the sine law and the cosine law last year, and they are hugely useful in physics. Embrace them. So you get the same answer. I prefer the tip-to-tail method, but you'll get full marks for either. Be okay? What we reading there, or turning the page, or you figured out where we are, or looking at a book, or what? Okay, it can wait. Next page over. How do we add vectors together, Shaq? Draw them. How do we subtract vectors? And what I taught you last year is I said we don't. By the way, there is actually a whole procedure for subtracting vectors. It is you draw them tail to tail, and then the resultant is from the tip of the longest vector to the tip of the shortest. Whatever. My strategy is, why learn an entirely new procedure when I can turn any subtraction question into an addition question? What's 5 take away 3? In your head, 5 take away 3? How could you turn that into an addition question? 5 plus negative 3. And that's going to be our strategy. Instead of subtracting vectors, we're going to plus the opposite. And by opposite, it's going to be just whatever was north will point south, whatever was east will point west. I like example 3, I like example 3, I like example 3. Example 3 is a nice question. Plane's ground velocity, velocity relative to the ground, is 240 meters per second due east. If the wind is blowing at 80 meters per second due south, what's the plane's air velocity? So again, we think V air, or V engine, plus V wind equals V ground. Mark, you were so good last time. What are they asking me to find this time, my friend? Read the question very, very carefully, please. And then where it says, what is the, read me that phrase. So not ground. You know what? They want me to find this. How would I get that by itself? Well, what's in front of the wind speed? A plus sign, so how would I move it over? This is subtracting vectors. As an equation, we would say this. The air velocity is going to be the ground velocity take away the wind velocity. No, it's not. Because how do I subtract vectors? I don't. What do I do instead? There's the equation. And ta-da, I've turned it into something that I already know. I've turned the page, so I'm going to put a compass rose on here. Things I've learned the hard way. Jenny, what is the ground velocity, magnitude, and direction, please, my angel? Ground velocity, read really, really carefully. Yeah. So 240, about that long. East to the right, plus. Read me the plane's wind, sorry, I guess not the planes. Read me the wind velocity, please, Jenny, magnitude and direction. Now, I want to add the opposite of that. So what's the opposite of 80 meters per second due south? With authority in your voice. You went 80 meters per second due north? Say it like you're confident, like you know. Ready? Preach! You go, girl. Absolutely. Now, 80 is about 1/3 as big as 240. I'll try and eyeball it roughly to scale. So I'm going to go yoink, about like that-ish. The reason I go roughly to scale is I don't want to solve for an angle that looks like this and get an answer of like 19 degrees, because I'll start to get worried. If the answer is supposed to be 19 degrees, I'd kind of like my picture to look about that big. Or if the answer is supposed to be, 75 degrees, I'd kind of like my picture to look that big. You don't have to. And there's going to be every once in a while for really nasty diagrams where I'm going to be totally off on scale, but it's just the way it works. Jenny, any suggestions on how I could add those two vectors together? Any thoughts on how I might draw them? Tip to tail, you say. Oh, my heart sings. So it's going to look like this. 240, 80. there is the air speed or engine speed. That's the direction the plane is pointing and how fast the plane's speedometer is showing. But its GPS would be showing something else. I know planes don't have speedometers. They have wind speed. I know. Anyways. Oh, do I need to go cosine law and sine law in this one? Oh, hey, this is great. I can go Pythagoras. So let's see. Airspeed is going to be 240 squared plus 80 squared, square root. 253? Meters, is it meters per second, or did I go kilometers per hour? Meters per second? At theta, where my vector originates from. Right here. Which trig function? Opposite, adjacent, like I said, usually tangent. Opposite over adjacent. Opposite over adjacent. You get 18.4 degrees. What of what? South of north, east of west? What of what? North of east. I love Foxtrot comics. I introduced my students to this The reason I like Foxtrot comics is Bill Ammond, who writes them, actually has his physics degree. In fact, when he was in university, he was notorious for doodling in his notebooks. And by his third year, he was drawing some comics for his profs. And they said, you know what, you should publish this. You're funny. And I especially identify with young Jason, the young little nerd boy. So here we go. It says this. His older brother, Peter, said, Jason, what pattern did I tell you to run? And Jason said, you said to go 10 yards out, then 10 yards to the right. And what pattern did you run? I went 10 root 2 yards at a 45-degree angle. And are they the same thing? If you add the vectors, sure. And this is football, not math class. Why do you think I rounded to 2 decimal places? There's the first one. Second one. I showed this one to my kids last year. It says this. Okay, here's the play. Go 40 yards downfield, then turn left and go 20 yards, then turn right and go 25 yards, then turn right again and go 30 yards, then turn right and go 30 yards, then turn left and go 10 yards, then turn left and go 15 yards, then turn left and go 20 yards, then turn left and go 50 yards, and I'll hit you with the ball. Peter thinks for a while. Won't I be right back where I started? Well, I can't throw very far. We have, on a clear sunny day, actually run that vector, and the physics is right. You do end up right back where you started. Shaq, I humbly suggest, work that into a huddle sometime. Come on, man, wouldn't that be great? Yeah? No? Okay. Or maybe that might be why you never get to be quarterback, right? Homework. So your homework, the first sheet is called vector additions, vector operations, and all it is just a rehash, a practice of. Pass them down, please. Get them done. Get them done, because I want your attention. Thank you, folks. All you're doing, because there's no numbers here, practice drawing the pictures. In next class, I'm just going to show you the pictures and see if you drew them right, because half the battle is getting the diagrams right. The second half is doing the trig. The second thing that I gave you is the, I forgot to print it here. Give me 1 second. Right-click. So the second one that I gave you, you cannot do every question on it yet. You might be able to, but in theory you can't. This is your ultimate vector kinematics review. It's the review for this unit. You'll get one of these every unit, and this is always due the day of the test. In other words, what I'll be doing every time I give you a test, I'll say for about 10 minutes, any questions from the big review? I'll do any last minute questions. Okay, No questions. We're going to start the test. Everybody hand the review in back there, and then I'll hand out the test. This is a review of the entire unit. If you complete these reviews, you will find almost no surprises on the test. What course is this? Physics what? Most of you are going to university. I will often put one nasty multiple choice on all of your tests every time because I want you to get good at thinking outside the box. I want you to get good at, hey, what do I do if I don't know what to do? Now what? That's a skill. But I will never give you a written question that's a surprise, and the vast majority of your multiple choice you will have seen before. Or, Rafi, I may have asked the question going forwards, and on the test it may be going backwards. So, on the test he gave me the answer and he wants me to find the original velocity, where in the homework he gave me the original velocity and said find the answer. That's always fair game going, if you know how to go this way, I'll expect you to know how to go that way. Take a look at this big review. On the last page, there are answers. Yes? Check, please. But also on my website, pitmath.com. Your website. If you click where it says, click here for today's notes, and you navigate your way all the way to block, what are you, G? G? I will always put both a blank copy of this review, because sometimes kids want to do this twice or they lose it, and I will always put a handwritten answer key. So the handwritten answer key, I tried to show all of my steps. Most of the time, if you're stuck, in fact, anytime, if you ask me a question from the review, I will always say to you, well, Josh, did you go look at my online answer key? Because if you figure it out yourself, I forgot the square root. That'll stick in your mind way better than me smacking you upside the head and saying you forgot the square root. So the rule of my class is before you ever ask me a question from here, go look at the online solution key and see if you can figure out from my work. And I tried to be very, very clear. I tried to write little notes and things like that. So usually most kids can figure it out. What questions can you do from this sheet right now? So I'm going to go back to the lesson here where it says homework, vector addition sheet, and then I'm also going to say from review, you are capable of doing, number 1, 4, $11, 13, 15, 17, 19, 20, 21, 24, let's see here. I think there's one more. 30. And then can you all take a look at number 33, please, for a second? There used to be scholarship exams, which were like really nasty ones. At the end of each review, I have included several of the old scholarship questions as well. Those ones are somewhat optional in that if you haven't done those and you hand in the review, I'm not going to freak. But those of you that are shooting for the 99 or 100%, well worth trying these because they're nerdily cool. And if you get the hang of these, you're in really, really good shape. Having said that, take a look at number 35, please. 35 is not a scholarship question. I'm not assigning it yet, but 33 and 36 is a scholarship question. And the way you can tell how many marks was number 36 worth, what does it say? just letting you know how I mark, every written question in Physics 12 is going to be worth 7 marks, which gives me lots of part marks to give out. But if you're looking on these guides, the scholarship ones are worth 10 or 12 marks. So the answer key for this will be online by the weekend, but you can work on all these. You can do the questions and answers right on here if you write small. You can do them on a separate piece of paper if you want to. I don't care. This, eventually, I will be saying, there will come a day, probably in about 3 lessons, where I'll say, and now you can do every question on here. And that'll usually be a couple of days before the test. Any questions at all? That make sense? So I'm shutting up. I wanted to give you about 25 minutes to work on the homework.